Hi there and welcome everyone. Thanks for joining the latest RightScale webinar, Game Development in the Cloud. We're going to take a little bit of a different approach today, and this one's going to focus on a live Q&A in a panel type format with one of our shared customers, TransGaming. Before we do, as usual, we're going to start off with just a couple quick polls. So they should be showing up on your screen momentarily. If you wouldn't mind just responding to the poll, and the answers will be presented to the entire audience so you all can get a sense of who's listening in today. First poll should be up. And if you just go ahead and click on what best describes your position there. Good. It looks like about half are developers and studios. Perfect. Just what we were hoping for. So next poll should be up momentarily here. And this one's about what stage are you currently at with regards to your game development. Excellent, thank you. So it looks like most of you are currently in development, so perfect. I think you'll find this webinar timely and topical for that. And then one remaining poll here should be up here in just a second. And this one's just your current hosting environment. So are you currently using the cloud like Amazon Web Services? Are you managed hosting? Or are you running this in-house on your own servers? Wonderful. So it looks like we have a pretty educated audience here. Most of you are doing stuff in Amazon already. Well, that's fantastic. Excellent. Well, thanks again, everyone. Appreciate your participation there. Let's go ahead and get started. I'm going to do a quick round of intros here. My name is Josh Frazier, and I'm the VP of Business Development here at RightScale. Joined by a variety of folks here from our gaming partnerships that we've set up. Roberto from TransGaming, he's really the star of the show, and he's going to be taking you through his experience using the respective services that you're going to hear about today. Jeff over at Amazon Web Services, he's their Senior Web Services Evangelist. Frank's with us from Couchbase. They're the providers of the Membase NoSQL solution. And then Craig's joining us from the performance testing solution, Apica. As with all our webinars, we have a live Q&A. And that Q&A is staffed by a fine gentleman by the name of Chris Nicolason. We did receive some questions during the registration process for the webinar for the panel members, so we have those and we'll be asking those to our panel participants. But please use the Q&A at any time to ask additional questions of the panel or other questions that you may hope to get answered, and anything we don't get to live today, we'll be sure and follow up individually with each question and provide you with an answer there. So with that, let's get started. Today's agenda, we're going to quickly walk through the challenges that we've seen associated with developing and deploying gaming applications in the cloud, then turn it over and do a quick interview of the respective services from our panel members today. And then Roberto's going to take us through a little bit in more depth his experience. You know, he's the end user here, he's the end customer, and we really want the audience to understand what his challenges were, what his decision-making process was, why he went the route that he went, and what the results were. And then we're going to spend the last half of the webinar having our panel discussion. So with that, let's jump in. So some of the challenges, you know, we've been at this for quite a while now dealing with gaming companies. And the realities that we see in the market today really haven't changed from where they were before. We're dealing with a very, very highly competitive space and getting more so, not less. You know, I think as the march continues on, and most recently with, you know, key market events like Zynga filing for their IPO, you know, the dollars at stake and the overall magnitude of the gaming market is just extraordinary. So very, very competitive. The cycle time is extraordinarily fast. So having tools and services that can allow people to develop and test and iterate becomes critical. This notion of success disasters, with when things happen in this new world of social networking and social games that are tied into social networks, things happen at a rate that otherwise, you could only dream about. And all this needs to be, controlled. So these are the 4 key challenges that we see with customers that we deal with. And the whole idea of the solution and the partners that have come together today is quite simple. It's to take the typical reality that we see with game developers today, where they're having to spend way too much time focusing on things other than developing their game and producing the best content and experience possible, and skewing that back to where it belongs. All right, so removing IT as a part of the focus equation. That's what this is all about. IT should not be a differentiator, but if you don't get it right, it can bring you down. So that's the goal here, is to give you a way to focus exclusively on developing the best game and the best experience possible. So what's this solution all about? Well, it includes the partners that are with you today. First, I'll just quickly introduce you to RightScale and who we are. RightScale is a cloud management platform. We automate the clouds that we support, both public and private, and most notably Amazon Web Services. We've been doing this for quite some time, almost since the inception of EC2, so we're coming up on 5 years. And we've launched an awful lot of servers. So we're proud to say that RightScale is the software management platform that's behind a lot of the most popular, largest, and most successful use cases and gaming deployments in the cloud today. Some notable logos that you may be familiar with. Each and every one of these companies that you see here is using the RightScale platform to deploy and manage their games in the cloud. How they do this is important to understand, and this is really the backbone of how companies like Couchbase and companies like TransGaming take advantage of RightScale in the cloud, which is the methodology or this notion of server templates. The easiest way to think about server templates is it's a playlist for your environment. And that environment can be a single server all the way up to a very complex multi-tier, multi-server, multi-region, multi-zone system. It's fully integrated, fully automated, with a repeatable process that's completely transparent. So what it does for developers and what it does rolling into production is it allows you a very repeatable way to easily design, launch, monitor, iterate over and over again in the Amazon cloud. Okay, so very, very important. You don't have to rebuild things from scratch. So that's the methodology that we take. One example of how this is delivered to the gaming audience is this notion of pre-built reference architectures. What you see on the screen here is just an example of a common reference architecture that we deliver to customers that are interested in using the NoSQL solution with RightScale and Couchbase and Amazon. The configuration that you see here is delivered as a single system using this server template approach, so you don't have to build it and piece it together from scratch. So with that, you're going to hear about this solution a little bit more. It is combining the best of the audience that you have today. So Apica's performance testing tools are leveraging pre-built Membase NoSQL server templates on RightScale. All of the orchestration and automation is done by the RightScale management platform, and it's all running on Amazon Web Services. So with that, I'm going to turn it over to Roberto, his experiences as an end user and the results thereof. Roberto?
Hey, thanks, Josh. So I'm here to talk to you a bit about TransGaming's GameTree TV service. But let me tell you a little bit about TransGaming. Next slide. So TransGaming's made life easier for game developers by providing tools that rapidly enable and simplify the distribution of games across multiple platforms. At the highest level, we have our digital distribution, and one of those is GameTree TV, and I'm going to talk more about that. And we also have GameTree Mac, which is our AAA title Mac portal, and you can see some of the games we've ported over to the Mac there. And then below that, we have a portability technology. It allows us to take PC games and run them on Linux-based OSs. And the way that's done is we take the DirectX calls and map them over to OpenGL. We take Windows calls, map them over to native calls, direct sound, direct input, and so on. So it takes a lot of the work out of the porting. And we also have a set of graphics tools like Swift Shader or Software Renderer. So we have a lot of tools to help game developers get on different platforms. And we also have a game studio. We've created a number of original titles, and one of the things we like to showcase with our studio is this multi-platform game development. So their latest titles can run on PC, iOS, Game Tree TV, and Mac OS. Next slide, please. So back to Game Tree TV. So it was a new platform. We started it about a year and a half ago. It delivers games on demand to users' living rooms from the cloud. So users browse Game Tree TV games as easily as they would change channels with the same remote. So you can see the first image, someone's watching, TV, and it's kind of a boring baseball game. You know they would rather be destroying zombies. So they launch the Game Tree TV widget from there and navigate to Plants vs. Zombies, and away they go, blowing up zombies instead of becoming zombies watching TV. So next slide, please. So on the developer end, they can leverage this platform we've created to take their existing games to millions of connected living rooms. And the user doesn't have to swap out different hardware like you would a console, so it's already just part of your service. So that's one of the main features. And we have things like favoriting, rating, different business models. We're fairly unique in that we have the rental model for games, and we also have unlimited play. So next slide, please. And then finally, so where does Game Tree TV work? You need an Intel-based smart TV like Sony's Google TV, or let's say like a broadband box. There's a free box Revolution that we're on, and you could also get it on a consumer box like a Boxy box. Next slide, please. So we built out this platform and took about 9 to 12 months to develop, and it provides the digital distribution of the games, so they're downloaded onto the set-top boxes or TVs. We provided an e-commerce platform, the rentals we talked about, and discoverability. We have the portability engine built into it, game updates and fixes, game-centric CMS, DRM, analytics and troubleshooting. So that, for one game, it doesn't make sense to build all that platform, but for multiple games, we think that you need that kind of ecosystem to really push your games. And then once that platform is built, then it makes it much easier just to take a game. So to port a game over to Game Tree TV, it can take between 2 to 4 weeks, depending on the complexity. And part of that is just sort of performance and graphics, making sure that that's all working well. There's also, once you take a game from PC, there's kind of usability issues of being further away on the TV. Input issues, again, you're not really fine mouse control, and it's not touch, so some work has to be done there, and localization for a global audience. Next slide, please. So then why the cloud? So when we were first estimating our capacity, it wasn't an easy job. It never is. But we have these kind of step functions of each time a new operator came, they could come with millions of users. And so trying to estimate that up front is a bit difficult. And then along with that, to add more complexity, because it is a TV-based system, you could have a TV spot that says, hey, go play this game after the Cartoon Network show, and you could have 10 to 100 times the traffic at those points, and trying to keep capacity for that spike is expensive and difficult again to estimate. So we wanted something that could elastically not only scale up, but more importantly for the bean counters that could scale down when it wasn't needed. So that's what drove us to the cloud, and we really liked the AWS offering, and so we had that section worked out. Next slide, please. then why RightScale? And like Josh was saying, that the server templates really is the key for us. So this repeatable server setup, and that could be moved to different server types. So if you just have an image of something, sometimes it won't work on, let's say if you go from 32-bit to 64-bit. But using the templating system, you could move your applications across those different server types. Then there's also the hardened application configurations, things like HA proxy, MySQL, Apache. So having some of those templates, used by hundreds of RightScale customers, and kind of learning from that from those templates. Then the second part was multi-cloud. How we love AWS, but we would have some operators that AWS might not have a data center nearby. So we wanted that capability of being able to have multiple clouds if needed. Then there's the high-level management view, so the accounts and the deployments, event auditing, monitoring, alerting. So all that stuff is, IT, more work that was already built into the platform, so that saved us a significant amount of time. Next slide, please. So this is just our whole kind of high-level architecture, and these are all the tools that we ended up using. We ended up using the HA proxy load balancing solution that RightScale recommended. We also have, that's the first level there. Then down below it, or along with that, there's a Varnish page caching system. Below that, we have a Python Django web services layer. And below that, we have a Redis object cache layer, so we don't have to hit the database for all the objects. They can just hit the object cache and MySQL for the storage of the data. And also ended up using Splunk for analytics and troubleshooting, AWS S3 for storage, EC2 for servers, and RightScale management and monitoring. And we were one of the early adopters of RightScale's Chef solution. So for server automation, we went that route. Next slide, please. So some of the lessons learned is that scripting, everything is challenging. It's not as simple as just going on a server and changing it and iterating on it. It does take more work to do that, but it pays off dividends when you need to clone a whole new system, when you need a QA version of it, when you need a load testing version of it. So we did a lot of load testing on our system, and we did it early on, and allowed us to experiment quite a bit and characterize our systems. Even things like trying out different server sizes to see how they perform, and allowed us to tune our systems before being live. We really enjoyed using Splunk. It allowed us to troubleshoot in seconds rather than minutes. One of the things with the cloud is you end up having arrays of servers, and it's not like you know each one by name. So having a system that gathered logs and allowed you to search through them was critical in our cloud development. And running in multiple availability zones, of course, a good practice, but having tools like AWS really made that easy and RightScale. And the cloud allows you to do some experiments that you normally wouldn't be feasible, like load testing a system of the same size as you would have in production. You could do that normally. That if you had physical servers, that would be too cost prohibitive. But it does allow you to do a lot more things that you wouldn't normally be able to do. And then that's all I have.
Yeah, well, thanks, Roberto. Hey, before we let you off the hook here, a couple of quick questions that came in from the audience. Is Game Tree TV based on streaming or different?
No, you download the games locally, so the games are served from the cloud, but it's not a streaming game solution.
And you guys also support Flash or Unity?
Not at the moment.
Okay. Excellent. Well, appreciate the overview. So the experiments that would not normally be feasible, your last point there is a perfect segue into our next area here. And now I'm going to turn things over to Craig, who's going to introduce us to Apica and how this fits in. Craig? Craig, are you there? I think you may be on mute. So apologies, looks like we're having some audio problems with Craig. Roberto, maybe we'll turn it back to you. And I understand that you and Apica worked very closely on the performance testing. Can you give us a quick little insight into what you use their tool for?
Yeah, sure. So let me see, is Craig back? You just said it. So what we needed to do is our first big partner was in Europe, so we wanted to test at a high load from a European location. And so we worked with Apica to simulate our usage patterns and apply, significant load into the millions of users. And
what levels did you test to? What kind of user volumes were you testing against?
So our model is a little different than just a straight sort of web access model. We have a fixed set-top box client that would download a lot of the catalog, and so we needed a way to fill those catalogs at in a sort of spike fashion. So we tested to 1.5 million at one point, and we were. It took a while to get there, so that's why I was mentioning, make sure to test early, because some things were kind of infrastructure tweaks that we had to do, and some things were, application level and database level. So having a partner that worked closely with us throughout that testing, was critical. And it wasn't, a lot of people just think, oh, load testing, you do it at the end, and it's a 1 week deal and you're done. We actually spread it out over about a month period so that we had time to test different tiers of our application, go back and do some internal experiments, and then come back and do it again. So Apica was very a good partner in that sense, in that they worked with us to spread out all that testing.
Great, appreciate it. Sounds like, Craig, you may be back.
Yep, sure am. Can you guys hear me?
We can. Great.
Fantastic. Yeah, if we can, Apica's been around since 2005. We're originally a Swedish organization, but now we're U.S. headquartered in Palo Alto, California, and down in L.A. as well. Working with on this TransGaming project was fantastic, because we got to really focus on providing an end-user analysis and doing load testing. And in this instance, it was working with TransGaming that had some special requirements. Can you go to the next slide? The initial challenges that we were facing is they wanted to know, one of their deployments was in France, and so they had, estimates in the millions, and wanted to make sure that their applications perform accordingly. And as everyone knows, when it comes to gaming, kind of performance goes hand in hand with that. And the other thing is that we really, because of that, we had to meet everyone's expectation in what they were looking for in that gaming experience. And what we worked on is really to basically load up and test from, because we're a global organization, we have test centers all over the world. And in this instance, we're testing as end users from France. And so we pushed well over 1 million users in the 15-minute period that we actually had to work within TransGaming's maintenance windows. We also, over the course of the month that we're working with TransGaming, we really identify those application and networking bottlenecks, and really just figured out how to size and optimize, and work with TransGaming and RightScale and everyone else on that as well. Ultimately, the outcome of all of this was, pretty efficient in terms of identifying those architectural bottlenecks, and web apps, and validating those tests with, being able to confirm that they can take over, a million users being able to utilize the system and the network, and really being incorporated in part of their software development lifecycle, which has proved invaluable. At the end of the day, it was just a pure, improved capacity and performance by over 400%.
Excellent. Appreciate the overview. So to do these large-scale tests, really requires an infrastructure like the cloud and specifically the scale and the different locations of Amazon. So that's a great segue to introduce Jeff Barr. Jeff, why don't you give us the quick intro on AWS?
All right. Hello, everybody. And Josh, thank you for the introduction. So I'm going to quickly go through the principal Amazon Web Services for the 53% of you who are not already using them. We have a number of services for computing, including the Elastic Compute Cloud or servers on demand. We have the ability to do large-scale parallel processing with the Elastic MapReduce. We have multiple different database services, including the relational database service where you can launch copies of either MySQL or Oracle and have the service do all the management for you. A number of different storage services, including the simple storage service for object storage, and then the Elastic Block Storage to let you create virtual disk volumes and attach them to your EC2 instances. Multiple different types of networking services. The virtual private cloud lets you create an isolated section of our network and then connect up to your corporate network. Route 53 for doing domain name service, Elastic load balancing, and auto-scaling. Several different types of management-oriented services. The Amazon CloudWatch collects metrics from these different services, makes them available and visible to you in the console. You can use those you can visualize the different performance aspects of your services, and you can also use those to do things like driving auto-scaling actions. And the AWS Management Console is a visual tool to let you see and manipulate all of the different services. Let's move to the next slide. In this slide, you can see how all these different pieces, or some of the pieces, fit together. We currently have 5 separate AWS regions located, 2 in the US, 2 in Asia, and a 5th one in Europe. The regions are broken down into availability zones, and you then launch EC2 instances within those availability zones. When you launch an instance, you always reference a particular AMI or Amazon machine image, which is effectively the boot disk for that image. The instances report metrics to CloudWatch where they can be used to drive auto-scaling. You get to protect your instances with security groups. You can place an Elastic IP address in front of them, and you can also use load balancing to spread out traffic across a cluster of instances that are all performing the same function. Different types of storage accessible to those instances include the ephemeral storage, which is local to the instance, and then Elastic Block Storage, which is a virtual disk volume mounted on the device, but which can be detached and attached to other instances as needed. You can take snapshot backups of those EBS volumes, store those in Amazon S3, and then recover them and use them to create other volumes or to restore volumes from backup. And one more slide. And also you should know that the Amazon Web Services are cost-effective. There's a pay-as-you-go based model, so there's no minimum charge for any of the services. You simply sign up for the services, create your account with a credit card, and then we bill your account based on actual usage. Pricing for all of the services is published and open and available to you on our website. No minimum charge for you to use the different services. There are different pricing dimensions for each service, and so for example, when you're using EC2 instances, you'll be paying by the hour of CPU time. When you're using storage services, you'll be paying for gigabyte months of storage. And then when you're using outbound bandwidth, you'll be paying for the bandwidth metered and charged by the gigabyte. Inbound bandwidth, there's actually no charge for data flowing into the Amazon Web Services. So that's a very, very brief overview, and I look forward to your questions. Back to you, Josh.
Great, appreciate it. Thanks, Jeff. And last but certainly not least, why don't we turn it over to Apica and Frank, if you wouldn't mind, Couchbase. Frank, if you wouldn't mind taking us through Couchbase and the Membase NoSQL solution.
Sure, absolutely. Thanks so much. So as you guys might be familiar with, Membase Server is a scalable NoSQL solution It's very heavily used in the gaming industry, and especially in the social gaming industry today. Actually, one of our largest customers is Zynga. Sure you're all familiar with them and what they do, and they're using well over 1,000 nodes of Membase today in their infrastructure. So why did they pick us? Why did others pick us? Well, because Membase is simple, fast, elastic. It's very, very easy to set up a cluster. You just install a package, and then each node is the same, meaning you can use all the RightScale templates on Amazon to easily grow your cluster or shrink your cluster as the capacity changes. It's very easy to develop with it. We're actually using the Memcached protocol, something that many of you will be using today in your application already. But instead of managing a MySQL tier and a Memcached tier, instead you simply have one tier that both serves as the permanent data store, because within the cluster we keep the data persistent on disk as well as replicate it to other nodes in the cluster, but we also have a built-in memory caching layer that will give you the very high performance, which on the next slide you see more about this fast aspect. So we could click, thank you. On the fast side, because we have Memcached built in, we actually have most of the key developers behind Memcached in our company. It means that you can now access your objects at typically less than a millisecond access latency. Of course, there might be some, depending on a bit on the network latency, but it's very, very fast. And that really is, of course, crucial because, as you know, if you are playing your game, nobody wants to keep waiting. The nice thing is that the performance doesn't suffer as you scale up. So as you go to clusters that have tens or hundreds of nodes, your performance latency stays flat. It really scales linearly. Now, on the implementation side, there is the high throughput data manager with the caching layer, and then there's a clustering, and those things are entirely separate. And with the clustering, if you go to the last slide, we can see on the elastic side that we really focus around the zero downtime. You can expand your cluster whilst there's load on your game, meaning you can keep adding nodes as your game suddenly maybe goes viral, and it keeps serving data throughout this whole thing. You can even do upgrades whilst the system is live, so you can basically balance in nodes with the new version, balance out nodes with the old version, and you can upgrade a cluster without the service ever not being available. And so this is very, very powerful. Now, one thing I just want to mention, this is a key value store Membase server that's out there today. We're actually just changing the product line a little bit. We've released on Friday last week Couchbase Server 2.0, which is the next in line of the Membase server product line. The key thing we are doing here is that we're actually adding CouchDB as the persistent data layer into Membase. It means that now documents that are stored in JSON format can now be indexed and queried. So we are adding indexing and querying capabilities both for keys as well as for the documents to the product line, making it even more exciting for social gaming or other gaming use cases, as well as, of course, other general things. Excellent. Thanks so much. So that was a quick overview of our Membase, and I'm looking forward to your questions.
Great, appreciate it, Frank. Hey, before we let you off the hook, a couple quick ones. Is 1.7.1 available for Mac yet? And if not, when can we expect it?
It should come out this week. We had some build issues we had with 1.7.1. You should be able to find it on the website this week. The same is true for the developer preview for Couchbase Server 2.0 that will also come out on Mac. And of course, we're supporting already Linux and Windows, and that's out there. And for Mac, you can download Membase Server 1.7 today, and the in-app upgrader will upgrade you as soon as it's available.
Great, appreciate it. So let's flow right into our panel here. The nice thing is, since we're all virtual, there's no chairs that we need to move. So appreciate everyone submitting their questions ahead of time during the registration. A bunch have come in during the webinar. Also, just to let everyone know, a bunch have asked. The slides will be available Usually takes about a business day to get everything posted online. Both the slides and the recorded audio of today's webinar will be available to everyone that registered. So no worries there. You can look through it at your leisure. So we just got a question here that just came in. I'm sure you get this quite a bit, Frank, so I'll start off with you here, which is why NoSQL versus MySQL?
Well, so there are a few reasons. One is, of course, the scalability. MySQL doesn't really scale very well. I mean, you can start to shard your data and kind of do it that way, but it doesn't scale very easily or very far. The other thing is, of course, access latency. If you just access MySQL, you have disk accesses, you get a long delay before getting your data, or rather a long delay for interactive systems. With specifically Membase, because of the built-in caching layer that's resource controlled, you basically assign a portion of your cluster RAM to caching, and you design it so that your working set lives in that cache, and as a result you get very, very low latency, like I said, sub-millisecond, and that means for gaming or ad serving, ad targeting, all these things where low latency is important, it pays off. And the other thing is the simplicity. You don't have any schemas, meaning that especially as you evolve your game, you might add different types of objects. There's no need to do alter table and try and work with your DBA to update the schemas for your game. Instead, you can simply start introducing new object types with a different schema, and it will just be part of the system. And even the indexing querying that we're adding now will just work with that schemaless nature, and you can simply identify the object types and do your new indexes on objects that have those fields.
Great, appreciate it. Next question, this came in during the registration process. Craig, I'll throw this over to you. What are the common struggles that you see customers go through with the automated testing procedures, and when do you recommend that's best conducted?
Definitely sooner the better. Be involved. I think that's probably one of the biggest or actually the more common times that we get involved with customers is when it's getting a bit too late, and that they're running up against their, their launch dates, those sort of things, and then come to find out that they've got some, some capacity issues or application performance issues, more importantly. So that's probably the most common thing is at what point do you engage a load testing organization like Apica, and it's definitely recommended to do as soon as possible, even when you're discussing architectural ideas too.
Great, appreciate it. Next one, actually, Roberto, if you don't mind taking this one. What types of optimizations does a game need for cloud deployment? So essentially what do developers need to have in mind when they're developing a cloud-based game versus something in their traditional data center environment?
Sure. I guess it depends on if we're talking about the actual game itself. If it were a cloud-based game, a cloud streaming game, you have a lot more resources on sort of the cloud side. When the way our games are, where you download it locally, the set-top box is a little more limited. It's an Atom processor, so the consideration is that it's not a PC, so it's going to have a little bit lower graphics and a little bit lower CPU. So, and besides sort of the optimization, I think one of the big differences is just what kind of screen a user is using. So, a lot of design changes. You have to make your cursors bigger if you're far away. Make click zones bigger. So. Again, it depends on what they meant by the optimization at what level.
Sure, and I think at a lower level, as far as the infrastructure configuration, one key difference is this notion of architecting for failure. Jeff, I know that's something we hear the Amazon CTO Werner talk a lot about. Can you elaborate a little bit about architecting for failure and what that means in the cloud? Jeff, are you there?
Okay, now that you've unmuted me. So architecting for failure basically means that you want to think about the fact that there is real hardware underneath this, and at any point, of course, something could break. And what we like to do is we give you all the different tools to let you spread out your functionality across a number of different instances and across availability zones, with the idea being that if you simply set up your architecture with the assumption that at some point something will break, you turn failure from this panic-inducing rare occurrence to something that you can actually simulate during development and simulate during testing, and that it turns into no big deal. You find testing to be, you test during that, for failure, you certainly make sure that things can fail over easily and as you go.
Great, appreciate it, Jeff. So a question that came in during Roberto's talk here. So Roberto, why server templates with all the platform layers on top of AWS? You know, that's certainly a question that we get a lot at RightScale. So why don't we just hear it straight from an end user's mouth? Why server templates in this approach versus the native tools?
Yeah, so I mean, one of them is just to not necessarily lock you into a particular cloud. So you can take a server template and move it over to another cloud provider. Sorry, Jeff, not that I would, but that's one of the reasons. I think another one is just being able to, let's say if I have a template for installing, let's say Membase or something, and I also want to install Redis on it and sort of my Python Django server. So if I have individual AMIs, then it's not really possible to merge them together. Whereas if I have a server template, I can apply those to one server, and now I have my different application types on the same server. I could separate them into individual servers. So it just gives you a lot of flexibility on how you run things.
Great, thanks, Roberto. Hey, Frank, over to you. What type of challenges when it comes to database scalability are unique to social games in comparison to a more traditional database-backed web application? What are you guys seeing over on the Couchbase side?
So I think where social games are different, or many gaming solutions are, is just that it's sometimes hard to predict what scale you need. We had customers who had games that over a weekend went glitchly from a few thousand users to a few million users because it somehow went viral, and so needed to scale up from the small operation to being able to serve millions. And we know that customers or users of these games are somewhat fickle-minded in the sense that if they try it and they find the experience is slow, the game doesn't seem to be responsive, they quickly go and play another game, frankly. And being able to do that and adopt very quickly to these changes at a cost-effective way is where I think both the cloud as well as then a very scalable data store like Membase are really the only answers to make this feasible. And I think it's pretty unique. And then, of course, as I said earlier, the low latency. And maybe another aspect is the ease of administration. I mean, with the RightScale templates on the cloud, with something like Membase that has a very easy UI that lets you monitor lots of things, it's very operations-focused, deployment-focused. It means that the sysadmin overhead to manage a whole cluster is very, very small. It becomes very simple. There's no, super specialized DBAs required. Like, if you've got MySQL sharded solution on any scale, you will need some wizards working that. And now, with this, we have commoditized it, and anybody can use those kinds of solutions, and that makes it, again, feasible for smaller studios as well to easily, deploy these new technologies.
Great. Yeah, a word we use a lot at RightScale is this word agility. And, all these solutions in the cloud computing, notion in general just introduces tremendous agility to everything you do and kind of moving to agile deployment as opposed to just agile development. So interesting stuff. Moving on here, there's a couple questions on what we can never get away with not talking about here, which is security. So, I'll throw it out. Why don't we start with you, Jeff? What is... how does AWS handle security? How should they be thinking about that? And then to you, Roberto, specifically as an end user, what steps are you taking and what are your concerns with accessing cloud resources as it relates to data security and end user security?
Okay, so I'll go first. So security comes up all the time, and we take it very, very seriously. We have a dedicated security team, and as part of the launch process for every new service, that team does a very in-depth review of the service. We published a lot of details of our security model at aws.amazon.com/security. There's several different white papers you can find there, including descriptions of our logical security, our physical security, our certifications, accreditations, things like SAS 70, PCI DSS, FISMA, ISO 27001, and so forth. So we have a number of large-scale enterprise customers that have gone through our security information. They've walked away, in most cases, very, very impressed. They see the documentation that we've provided. They see the certifications, and quite often we hear from them kind of through unofficial channels that they'll say, when we really dig into AWS security, it actually looks a lot better than what our own organization is doing. And we can do that in part because we do have the retail background, so we've had to take very good care of people's personal information and credit cards, and also because the scale at which we're running AWS gives us the ability to invest in things that might not be possible if you were running your own servers in your own data center.
Great. And Roberto, when you were deploying here, what were you most concerned with, and what steps did you take to alleviate those concerns?
Yeah, so I mean, some of the classic, just access to resources that shouldn't be accessed. So making sure that anything that we considered sensitive, we encrypt. Using security protocols as needed. Are having the virtual private networks into anything that has to go to some of our internal systems. I mean, so far we've been really impressed with the tools that Amazon and RightScale have offered in that space also.
And specifically with game data, where is that kept? Is that in the cloud? Are there other options? What's your take there?
Yeah, we are storing it in the cloud, but again, when it is sensitive data, we do encrypt it. Just adds another layer on top of the security model that's provided by Amazon.
Right, and I think Jeff, it's probably worth noting and elaborating a little bit. I mean, the whole notion of this utility is it puts complete empowerment to the end user, and this notion of responsibility to encrypt in transit, encrypt it at rest. I mean, all that ultimately extends back to the end user, and you guys provide a lot of flexibility and options, but don't necessarily dictate any particular approach. Is that right?
That's a good way to think of it. We're giving you a lot of components that can be put together in a lot of different ways, and so we'll basically take care of securing everything up to the infrastructure level, and we're then going to be booting up these different kinds of operating systems. It's then up to the user of that facility to say, are we going to actually keep the OS itself secure, and are we going to keep the application secure? So we do everything that we can. We then give you some guidance and some tools to do everything up and above that.
So you're in complete control as an end consumer.
Exactly.
Great. So let's throw this back over to Couchbase here. So gaming apps are typically write-heavy. How does Membase compare to MySQL in this particular case? So write-heavy apps versus read-heavy.
So there are a few things where we help, and actually specifically in the gaming case, some of our biggest customers like our write deduplication. But actually, before we dive into that very technical detail, let me maybe say a few things there. So there are two key things. One is, of course, it's clustered, meaning that you distribute your I/O across all the nodes in your cluster, which means if you use EBS, each node has a certain I/O bandwidth it can use, and so as you have more and more nodes, you get more and more I/O bandwidth, so it becomes easy to scale, opposed to trying to buy bigger and bigger servers as you would with MySQL and trying to get more and more I/O bandwidth on a single machine. So that's the first thing, you can scale I/O bandwidth this way. Now the second thing is that because all reads and writes go via the memory caching layer, you also get a buffer basically. So a write into Membase, once it's received by the node that's responsible for that key, it will be in memory there. It will then be replicated out to other nodes where, depending on how many replicas are configured, but once it is in memory, it will be moved asynchronously into a write queue. Now this means that you use this write queue as decoupling writes directly from disk, meaning if you have some peak times, so we see on some of our bigger customers, for example, that the write queue will grow at their peak times and then it will drain and go down in size again as the evening is over, for example, and as people are playing the game, depending on their cycles. Now, there is a synchronous option where you can say, no, I need to wait until something is persisted to disk, but in general, this decoupling makes a lot of sense because you've got the replication to the other nodes, so that in case if a node goes down, as we just showed, that might happen, but then simply the autofailover would kick in and the data would be served from the other node where it was replicated to before. And then lastly, in addition to this decoupling, we have actually specific write deduplication that lowers your net bandwidth required. Especially in social gaming cases, what you often find is that there is a document or a value, for a key that gets modified frequently in succession. It happens, somebody's accessing their base, their farm, their object, and makes some modifications which results in very quick successive updates to the same thing. Now, game developers, or as part of the configuration, you can set certain minimum data ages for persistence so that basically an item won't be written to disk until it has reached a certain age in the write queue. And you can use that it means that if there are multiple updates to an object within that time period, that only the last update will be written to disk. And so this is very powerful for those social use cases where objects are modified frequently and you don't really need to write each of them to disk, and so you just net save bandwidth as well, in addition to spreading it out and decoupling it from I/O as I just described.
And Frank, a question that just came in from the audience here. When backing up Membase nodes using EBS, is a backup of every node required or only the single node like MySQL?
Well, so this Membase isn't a master-slave setup. It's a peer-to-peer, meaning that each node has some active data and some replica data. So as a result, if you want to back up everything in your cluster, then you need to do a backup of each node, because each node has some active data that needs to be backed up. Now, you can back up individual nodes, but in general, you would want to back up every node in your cluster. And then you can restore those as required. But of course, the primary way of recovering from failure isn't to restore from backup, but is to simply do a failover and use the replication, so use the replica of the data that's in the cluster already, so that you don't need to restore from backup. That's really only for catastrophic failures or for rollback if you want to go back to a specific time in your system, for example.
And a related question on EBS that came in earlier, Jeff, if you wouldn't mind, can you explain a little bit more about EC2 to S3 transfers for storage and how pricing works for both the bandwidth and then the end storage component?
Sure. So data transfer into AWS from anywhere out on the internet, there's no charge for that data transfer. Data transfer within a particular EC2 availability zone, there's also no charge for that. There's a 1 penny per gigabyte charge between zones, and any transfer from EC2 back and forth to services. So EC2 writing data to S3, EC2 reading data from S3, there is no charge for that bandwidth. All these details are actually published and available on our website. I know we also had a related question about how do you get large amounts of data into AWS. We do have a service called AWS Import Export that allows people to ship us empty disks, and we can write data onto those disks and return them to users if you want to get large amounts of data out of the cloud. Or you can send us disks full of data, and we'll attach those to the internal network and copy data off of those disks and onto S3 or EBS at high speed.
Great, appreciate it, Jeff. Let's change topics here and talk a little bit about alternatives here in terms of application language. So, a question that came in during the registration. Roberto, I'll kick this to you. PHP seems to be a popular choice for end-to-end communications with the game client. What would you attribute this to, and what other alternatives should developers consider as an appropriate language here? And then another question that came in related, if you could address as well, which is, do you have any particular advice or preferences as it relates to technology on the back end and are some more challenging to scale than others?
Sure, that's a big one. Okay, so why is PHP more popular? I guess I would say hosting environments they allow PHP way more than most other languages, and also just the fact that it's a scripting language versus compiled, so it does allow people to iterate quickly. We do use PHP in some of our products. For this product, we went Python and Django, just because of I guess the more object-oriented nature of Python and sort of the tools that Django provided. Sorry, other parts of the question?
Yeah, and other than PHP, any other recommendations on languages?
So I guess in the context of what we're talking about here, so using something like AWS or RightScale on top, you control the whole stack, so you're no longer sort of tied to what your hosting provider would provide. So it's pretty open. I mean, it's more just what you prefer and what developers you have available. Yeah.
Great, appreciate it. Craig, if you're still with us, question back to you on the testing experience with TransGaming. How many people were involved in that, and how long did that take? Can you give us a little peek behind the curtain here of what went on your end?
Yeah, I mean, it was well, from a timing standpoint, we worked with TransGaming for about a period of a month, really, combing over the original requirements and developing the scenarios and identifying the key things that we need to test for so it's as accurate and real as possible. I would say right off the top, there were about 4 people on our side that were working with Roberto and his team, kind of going through that whole process of the requirements building and doing the testing, and then working with them on recommendations on tuning and optimizing their infrastructure and application, that sort of thing, and then doing the retests again, and just being able to really evaluate the 400% improvement.
And do you continue to test? I mean, what's happened since the initial launch?
Well, now what we're working on is just working with Roberto on a regular basis in terms of when they're looking at onboarding new major customers, those sort of things. We discuss doing new tests with them, and especially if the requirements change, and really trying to integrate with their software development lifecycle.
And is that typical? Do you see a lot of the customers you work with are doing ongoing testing as their environment changes?
I think, especially in the gaming, they're really learning the return on investment, because at the end of the day, it's protecting their investment. They're able to conserve money if they need to, because of the tests that we do really shows the type of package, the type of sizing they should be working with. And it also helps them understand, like, if something goes viral, what they're going to be able to handle. And it really comes down to, a lot of the nuts and bolts that we deal with is what's going on in the application as opposed to the infrastructure, because, as everyone knows, I mean, it's, with Amazon and what RightScale does, it works extremely well, and TransGaming is an excellent example of that.
Great, Jeff. I'll put you on the spot. 2 related questions here, which is, with this global market here, where Amazon is with these regions is certainly always a hot topic. How are these regions chosen, to the extent you can provide a little insight there? And also, specifically, are there plans for entering the China market?
Okay, so regions are chosen based on what we can actually see of traffic behavior that we see coming into our data site. So we can see effectively where the users are coming from. So we look at that as one guide. We spend a lot of time talking to our customers and really listening and learning from them to get a good sense of where they make sense for them strategically to have servers in order for them to address different markets. With regard to China, can't really say anything. Certainly we have demands from a number of different locations around the world where everybody likes to make a justification for having data centers in that particular part of the world. So we don't tend to pre-announce locations. We do have a fairly good roadmap internally as far as new locations that they're working towards. So what I can say is that we do have additional regions underway.
And I think from an end user standpoint, which RightScale is both a partner and a customer of Amazon's, we can certainly attest that the approach that Amazon has taken in rolling out new regions has been phenomenal for a variety of reasons. But one in particular is when they do launch a new region, it has been shown every single time here with the 4 additional regions from US East to be robust, feature-rich, delivering the same set of experiences around the underlying resource behavior that we're used to with the Amazon East region. So if that weren't the case, it would be an absolute bear to take advantage of. So, Roberto, maybe I'll kick this one back to you. Challenges specifically to maintaining your RightScale server templates. So what do you do as it relates to maintaining templates and any challenges you've encountered?
Yeah. So we decided to go kind of the chef route. Partly because of that, we wanted a little more traditional sort of software development, using Git and being able to use source control directly in the command line. So that's one of the things we do. We also have one of the reasons we do like RightScale is the ability to clone a full environment quickly. So we have a clone QA environment. We test our templates there. Then if they pass that, then we move them over to our staging and prod environment. So it's been a nice way where we're treating server configuration like we treat our source code. So.
And so, Roberto, you mentioned it earlier, but just to reiterate, you were one of our first end customers using the new chef-based RightScale server templates, and thank you for all your efforts, and we got a lot of learnings back from you. Can you talk a little bit more about the best of both worlds there? I mean, combining chef cookbooks with server templates.
Sure. Let me see. I'm sorry, I'm trying to think. So being able to do traditional source control, on the server templates themselves, and then sort of mix and match with templates that RightScale's pre-written either in RightScripts or in cookbooks has been really nice, and that not everything that we wanted was in Chef. So we did have some templates like the MySQL templates that were tried and true, and so we were able to mix those two models fairly easily, and so that's been nice. A lot more variety of templates than if we just used, let's say, Chef or just used RightScripts.
So you're able to continue to use your preferred source control mechanism. I think you said you're using Git, right? And then
right.
Use chef-based for single server configuration, but then incorporate that into the broader system management that the server templates and the RightScale deployments allow you to do and to automate.
Right. And one of our goals was to be able to kind of run the code locally so that development could happen fairly quick, and having that mixed model has allowed some of that. We're still fine-tuning that process, but we're getting there.
Great. Well, thank you again. Appreciate it. Well, with that, why don't we cut things off there? And I want to first thank everyone for joining us on the webinar. We appreciate all your attention and great questions. Any questions that we didn't get to live or any questions we didn't get to on the Q&A, we will follow up with and provide you answers. Any follow-up questions, you can always reach us at sales@rightscale.com. If you want to hear more about Roberto, I'm happy to give you his cell phone number. So Frank, Craig, Roberto, Jeff, thank you so much for joining us. Again, these slides will be available, audio and video. Give us about one business day. They'll be posted at rightscale.com/webinars. And if you're interested in trying out any of these solutions, please do so. There's very cost-effective ways to do that, practically free. Amazon has a free instance type that's available for up to a year. Just go to aws.amazon.com and get an account there. And then RightScale will be happy to provide you with a developer account or talk to one of our sales reps, and we'll be happy to upgrade you to try out a VIP account for a limited period of time. So please try things out, get some learnings, fire off questions. We're here to help. Good luck with your game development, and we look forward to talking to you all soon. Bye for now.